Hello everyone. In this video I will be explaining about composition of functions. With numbers we can add, subtract, multiply and divide them, but with functions we have one more operation that we don't have with numbers. That's called composition. The composition of two functions f and g is notated as f, a little circle, g and x. This is read as f composed with g of x, or f of g of x. So be careful about the notation. This looks similar to the multiplication. Remember the multiplication notation. It was f times g of x, but in composition f of g of x. In composition we have f bracket g bracket x. In multiplication f by g in a bracket, or not in the bracket, of x. X is in the bracket, but here there are a lot of brackets, so be careful about this. Plus, in composition of functions, order matters. Order matters. So f of g of x is not always same as g of f of x. So it is same for some functions, but it is not always the same. So order matters in composition of functions. So the composition of functions means we take the inside function, g of x is the inside here, and put it into the outside function. So take the inside function, use the inside function as an input of outside function. Inside function's output will become outside function's input. Output of inside is input of outside. We just take the inside and pour it into outside function. For example, f of x is given as 2x minus 3, g of x is given as x squared in this question. We are asked to find f of g of 3. So we always start on the inside and work our way out. We start inside. The inside function is g of 3. So the first thing we need to do is finding g of 3. This is evaluating functions. You just need to substitute 3 for x in function g. We need g of 3. So what is g of 3? G function is x squared. Just have to replace your x with 3. G of 3 equals 3 squared, which is 9. So the output of inside function is 9. It becomes now input of outside function. So now we are looking for f of g of 3, which is 9. Similarly, I will take 9 and substitute it back into function f. Careful, the function is f this time. So I put 9 for x in function f. So it is 2 by 2x minus 3. Replace your x with 9. 2 by 9 minus 3. 2 times 9, 18. 18 minus 3 is 15. Like that. Let's take a look at the opposite. Let's reverse the roles of f and g. Now the input function becomes f, output is g. So take the inside function and put it into outside function. So the first thing we need to do is evaluate the inside function, which is f of 3. What is f of 3? You plug in 3 for x. So 2 by 3 minus 3. It is 2x minus 3. Replace your x with 3. 2 by 3 minus 3. 2 times 3 is 6. 6 minus 3 is 3. And now the function becomes g of f of 3 becomes 3. So plug in 3 for f of 3. Now the output of inside function becomes input of outside function. So g of 3 is the thing we need to evaluate. G function is x squared. Replace our x for 3. So it's gonna be 3 squared, which gives you 9. So g of f of 3 is 9. G of f of 3 becomes 9, and f of g of 3 becomes 15. So as you can see, changing the order changes the results. 15 is not equal to 9, so it verifies this note. Another thing about this section is writing the composite functions. The first thing is evaluating the composite functions. The second thing is writing the composite functions. So let's write the composite functions. So similarly, instead of writing the numbers, substituting the numbers, we will substitute the functions. So the inside function is g of x in the first part. You pour g into f. Take g, put it into f. So this becomes f of g of x, which is square root x plus 2. Just write square root x plus 2 for g of x. And now, this is evaluating functions. We have another thing, not just x, we have square root x plus 2. All we have to do is insert square root of x plus 2 for x in function f. Our function f is 3x minus 2. You replace x with square root x plus 2. So it becomes 3 multiplied by x, which is square root of x plus 2, and minus 4. Simplify this. Distribute 3 to the bracket. 3 square root of x, 3 by 2, 6, minus 4, 2. 3 square root of x plus 2 will be composite functions. For part B, it is the opposite. We reverse the roles. This time we plug in f into g. So it becomes g of f of x, which is 3x minus 4. And now my new function will be g of 3x minus 4. That means we take x, every axis will be substituted by 3x minus 4 in function g. So this becomes square root of, instead of x, we have 3x minus 4 plus 2. No simplification. So those are our composite functions. So the question has another part. It is asking about the domain of each. So how do you find domain of composite functions? It is given in the definition, in the explanation for the rule. It says the domain of the composition function is all values of x in the domain of g such that g is the domain of f. This means, this looks complicated. This means domain of the composition function f of g of x is equal to domain of f of g of x intersection with domain of inside function. Our inside function here is g of x. So it is not enough to find the domain of the results only. We just need to check the inside function too. If there is any restriction, we have to be careful about it. So we take the intersection between the inside function and the result. So that's how you find the domain. So let's look at the composition functions here. So what is the domain of the result? We have square root of x. So the domain of square root of x here, the numbers under radical can't be negative, right? So the domain will be x values greater than or equal to 0. This is the domain for the result. Domain for the inside function, let's look at the g of x. Here is the g of x. Domain of the inside function is also the same. We have square root of x plus 2. It is also x values greater than or equal to 0. So their intersection is the same. X values greater than or equal to 0 is the domain for this composition function. What about part B? Part B, look at the result. In the result, we have square root 3x minus 4. So there is a restriction here. So numbers under radical can't be negative. We just set the stuff under radical as greater than or equal to 0. This is the domain of the result. What about domain of the inside function? We have f of x as an inside function. Domain of inside function, that's a polynomial function. There is no restriction, all real numbers. So the composition of, the intersection between all real numbers and this is this. The smaller domain will be our domain. Isolate x, bring negative 4 to the other side. 3x is greater than or equal to 4 and x is greater than or equal to 4 over 3. So that becomes my domain of part B. Let's solve one question that inside functions domain and the results domain are different. F of x is x squared, g of x is square root x minus 1, and we're asked to compose f and of g of x. So g is the inside function, so plug in g for f. So it becomes f of g of x, which is square root of x minus 1. Now it becomes evaluating functions. We just have to substitute x, square root x minus 1 for x. So every x in function f will be switched with square root x minus 1. So it's gonna be f of square root x minus 1 equals square root x minus 1 squared. So there's a square outside and square root, they will cancel each other. This is x minus 1. So about the domain, at first sight we may say x minus 1 is the result. There is no restriction, so domain is all real numbers, which would be wrong. We also have to check the inside function. So domain of outside function, domain of the result, domain of result is all real numbers, right? X minus 1's domain is all real numbers. There is no restriction. And domain of inside function, our inside function is g. Domain of g of x, since there is square root, there is a restriction. So under radical, we cannot have negatives. So we will say x minus 1, the stuff under radical is greater than or equal to 0. So x is greater than or equal to 1. So domain of the result is all real numbers. Domain of the inside function is x is greater than or equal to 1. We take their intersection. So the smaller interval, the smaller domain will be our domain. So x greater than or equal to 1 is the domain of this composition function.